Hello, guys and gals, and welcome to our first trial video for our flipped classroom. We're going to start adding these videos, and hopefully it's going to help us better prepare for the AP exam coming up this semester, okay? So, in this video, we're starting Chapter 5, or Unit 5, which is on kinetics, okay? And specifically, we're going to be starting with sections 5.5a and b. I know it's kind of weird to start with 5.5, but it makes more sense to start kinetics here, okay? So, what is kinetics? What's chemical kinetics? What is this unit going to be talking about? Basically, chemical kinetics is discussing how fast or slow a reaction occurs and why it's fast or slow. And eventually we're going to be looking at what can we do to make it go faster or slower. Okay? So this is all focused on what are the molecules doing to make the reaction happen, and how can we mess with that to make the reaction go faster or slower. Okay? Now, in order to get to chemical kinetics, we have to first understand what are the molecules doing in order for a reaction to occur. And the thing that talks to us about that is called the collision model or the collision theory. Okay? Collision theory tells us what the molecules have to do to make or break those bonds that we know have to be broken in order for a reaction to occur, right? So, it gives us three major requirements that particles have to meet in order for the reaction to occur. And particles can be anything. They can be atoms, ions, molecules, compounds, you name it. All particles that are reacting have to follow these three requirements, okay? And now the first requirement is, and you're going to think that it's silly that I even have to say this, but the first requirement is that particles have to collide, okay? They have to actually physically collide into each other, like a car crash, okay? Now, most of the time, people forget this step because it's so simple. But you cannot forget this step, okay? Because if particles have to collide, and we can affect the number of times that they collide, then we can affect how fast or slow the reaction is occurring, right? So this step is the most overlooked when we start talking about what can we do to this in order to make the reaction go faster or slower. So, in order for a reaction to occur, particles have to collide. And if we think about it like, well, why would they have to collide? It makes sense when we first start thinking about it in terms of breaking bonds. So if these two things are two particles that are trying to react, if they're just kind of sitting next to each other, nothing's going to get broken. They're just going to sit next to each other. But if they collide into each other, we can start breaking things, right? So we can break bonds via collisions. But we also have to make bonds via collisions. The fact is, they're not close enough. Even if they were this close, they're not going to be close enough in order for the electrons to be attracted to the opposite nucleus to form bonds unless they collide either, okay? So particles have to collide in order for a reaction to occur. Now, the second requirement that we're going to see is that not only do they have to collide, but they have to collide at the correct orientation, okay? And if you don't like that word, you can think of it as correct angle or just correct position, okay? They have to collide at the correct position. If you're wondering why, I'm going to use a quick example, but I'm going to give a disclaimer first. This disclaimer is every particle that reacts, that collides, has to bond or has to collide at the correct orientation. Okay, I'm going to use polar molecules in my example, but every particle that exists, polar or nonpolar, has to collide at the correct orientation for a reaction to occur. Okay, so let's go to my example where we have this really large, complicated polar molecule. I know that it's not a real molecule, bear with me. And this really large, complicated molecule, okay? And they're both polar, meaning they've got partial positives and partial negative sides. Now, they're supposed to run into each other. They're supposed to collide, they're supposed to react. That's what we want to happen. But let's say that when they go to collide, this is the way that they're oriented. Now that's a problem, because we happen to know that like charges repel each other. So if this is their orientation when they go to collide, if they don't have a lot of energy, first of all, they're going to start repelling right about here, and then they just won't even collide at all. They'll just repel each other away. If they do somehow have enough energy to overcome that repulsion, they're going to use up all that energy trying to overcome it. So by the time that they collide, they're still not going to collide very hard or with a lot of energy. And so again, you're not really going to have the collision that you need to have in order for a reaction to occur. So like I said, collision at correct orientation has to happen with all particles, but if you're wondering why, maybe polar compounds can kind of help you think about that, okay? The final requirement that we see in order for a reaction to occur is that particles have to collide, they have to collide at the correct orientation, and they have to collide at the correct energy, okay? And we call this energy the activation energy. Activation energy is the energy that particles need to collide at in order for a reaction to occur. This is the energy that we need to break or make those bonds, okay? These three things, these are the three things that are happening every time you have a chemical reaction at the molecular level. And so therefore, these three things are the three things that we can manipulate in order to make our reaction go faster or slower. But that's what we're going to talk about at a later time. For the last part of this video, we're going to talk about the fact that collision theory technically only applies to something called an elementary reaction, okay? Now, this is not something we've talked about before. We've talked about single displacement and double displacement and redox and acid-base and all of those things, okay? But any reaction in the world can be classified in two ways, elementary or complex. Simple or complicated is another way that you can think about it, okay? An elementary reaction is elementary, my dear Watson, right? It's very simple. It occurs in a single step. Your things collide, boom, there's your products, you're done. One step is all it takes. A complex reaction happens in several steps, and when that happens, it produces something that we call an intermediate compound. An intermediate compound is formed in the middle of a reaction, but then it's immediately used up. We do not see it as a product, okay? And it might be easier to understand that if we take a look at this with an example, okay? So if we've got hydrogen gas reacting with nitrogen monoxide, it's supposed to give us nitrogen gas and water, okay? But what we tend to see is that the 2 moles of nitrogen monoxide are actually going to react first. They're going to collide, and they're going to give us N2O2. Wait a second. If this is the balanced chemical equation, there's no N2O2 in that. And how many times have I told you guys you can't just magically input atoms into a reaction? So where did this even come from? Well, the fact is, this is a complex reaction. It happens in several steps. So we didn't just magically produce N2O2. The reaction at this step is producing an intermediate compound. N2O2 is going to be formed by the reaction like it is by this step, but then it's immediately going to be used up. Okay, N2O2 is going to react with some of that hydrogen gas, and it's going to give us some water, but it's also going to give us some N2O. Again, this is a compound that we do not see in our balanced chemical equation because it's an intermediate compound. It was formed by the second step of this reaction, and it's going to be used up, and we are not going to see it in our final products. Okay. Finally, that N2O2 is going to react with some more hydrogen gas, and we're going to be left with our nitrogen and our water, just like we expected to. But we couldn't have gotten that nitrogen and water without those other 2 steps happening. Okay. So a complex reaction occurs in several steps, and it produces intermediate compounds, which are immediately used up. We do not see them as products. Okay. Now, technically speaking, each of these steps in a complex reaction is an elementary reaction, okay? So the collision theory does apply to every reaction. But in a complex reaction, it's just applying to these elementary pieces, and that's going to be particularly important for us to know later on in this unit. So let's just do a quick recap of what we've talked about in this unit. We talked about collision theory and the fact that in order for a reaction to occur, your particles have to collide. They have to collide at the correct orientation or position, and they have to collide at the correct energy, also known as the activation energy. We also talked about elementary and complex reactions. Elementary reactions occur in a single step, and complex reactions occur in several steps, and they make intermediate compounds. Okay? I hope this helped, guys. Let me know if you have any questions. If I can turn off the video.